2.
This is 2, yeah.
2s2. Same thing. Now 2p. 4. 8 total. Now we got to fill these again. The 1s, 2s. So I'm going to put 2 here. 2 here. Now I got to put 4 in here. I'm going to fill them like we just showed. You go 1, 2, 3, and now the 4th you got to go back here. That's all. Hunt's rule, one at a time. And the Paul exclusion principle says pointing in opposite directions. That's the configuration of oxygen. Oxygen is a, what does that oxygen like to do? What kind of ions does it form?
Like the gain.
Like the gain, how many?
2.
Okay, if I put 2 more electrons in here, where would they go?
They become inert noble gas.
Right, it looks just like this. What element has that with 2?
Neon.
Right. Exactly.
But it'll have a different number of photons.
Protons we haven't changed, right? We're only changing electrons.
So what is that?
They have negative 2 charge, right?
Oh, yeah.
Right. Oxygen, the oxide is negative 2.
Oh, so it turns into oxide.
Right. All right, let's do magnesium. Let's do magnesium. I got to put all the electrons, right? Put 2 here. And I got to do 2 here. And I got to go across here. 1, 2, 3, 4, 5, 6. That gives me how many? 10? So, the last 2 have to go right here. And we showed in the periodic table, those 2 columns, the alkali metals and alkali earths, that's in the last 2 electrons are in that S block. In the case of magnesium, it's the 3rd row, so it's the 3s. Sodium would the 3s. Calcium would be the 4s, and so on. Now, if we were to write the configuration instead of the diagram, we go 1s2, 2s2, 2p6, and 3s2. When we start getting really big atoms and we start going down, this thing can get really long. You got to do 4 S's and 3 D's, and oh man, there's a shorthand way to do it. And that is, you take the previous noble gas before magnesium, put down neon, 3s2. A lot easier. Remember, this is neon right here. So that's easy.
That's how they use the table, periodic table, right?
That's easy. So, let's do potassium. Let's do potassium. One thing that'll help you when you have to do these, when you start getting into the certificate, is located on the periodic table.
Yeah.
And figure out where the very last electron is going to be. Where's potassium? Row 4, right? You have a marker? There it is right there.
So could you just say argon and then 1
Yes, you
electron in its last,
Absolutely.
or
Right?
1s?
What is this?
What is this? 4s.
4s.
Oh, okay.
It's 4s.
It's 4s1.
It would be argon 4s1 if you want to do the shorthand. If you want to do the long way, we got to fill all these guys up, right? We're going to start all the way across from here and go all the way down. Gotta go all the way down, like you back and forth. 2s, 2p, go that up, 3s, and then 3p. So locating it on the periodic table will help you know when to stop. Right? You stop here and just fill everything up down to there.
Can you just do the shorthand way, like adult?
Depends on what you ask. You're going to have too close over there. Have too close. You circle the shorthand. So far,
How'd you get argon gas out of that?
well, the previous noble gas, argon, has how many electrons? 18, right? So if you look on here, let's go right. Come on. The other one. That was there. Why didn't this one go? If you look at argon, okay, 18 electrons. That's this. Argon. The last noble gas. Look on your periodic table. This was fancy in here. Argon is the last noble gas just before that. You just say argon before S1.
So for cesium, you would just say a xenon and fix that one.
Cesium, right. These will be right here. Check. Yep. Yep. Now, let's talk about transition metals. Then we're thinking a little bit tricky. You got to be careful. You got to be careful. Because remember, the D is one block lower. We go from 4S to 3B. So we're going to do a nickel. 28 electrons. You know right away nickel is in the D block. That transition metals are called the D block. So the last electron is going to be the D. Right? Can hold up to 10, right? D has 1, 2, 3, 4, 5 levels, 2 electrons each. So, where's the last electron going to be in nickel? Let's find it on the periodic table.
Argon 28.
How many over is in nickel? Or how many electrons in the D?
28.
8 went over, right, in the D block?
Isn't it already like pretty much stable though?
Pardon?
Doesn't it already have a stable, like, 8 outer shell?
No, 28. It's got 28, right? And how many electrons in the D? How can you tell how many D electrons it has?
And the number above the...
You got to count the row over, starting with scandium, which has 1 electron, and just count your way across. Nickel is the 8th one over, right? So we're going to have 8 electrons in here. And then we're going to fill everything below it. I don't remember the slide, because I thought I had it. So let's fill them up. 28 electrons. 2, 4, 6, 8, 10. Go up to the next level. 12, 14, 16, 18. Then we got to go to 4S. Right?
In the 4S row, you start...
We go from 3P to 4S, right? Look at your periodic table. 4S would be the potassium. Right, so 2 electrons here. And then how many here? 8. 2 here, and then we got to move 8 more. 8 more. And that's nickel. That's nickel. Just locate it, figure out how many electrons, and then backfill. Starting with hydrogen, 1s, 2s. The same thing.